Welcome in the fifth section of our course. In this section, we'll be performing Subgraph operations, so we'll be doing more complex stuff than in the previous one. In the previous one, we learned what the graph is, how to construct a graph, and simple GraphX API. In this, we'll be looking at the subgraph operations, at the neighborhood aggregations, we will be counting degrees of vertices, and we will see a graph builder class. And this is a first video in which we'll be performing subgraph operations. So we'll be creating a subgraph of graph, we'll be defining properties of a subgraph, and extracting subgraph. So we are getting back to our project, and this time we'll be executing structural operations method. So let's see that method. Our graph will be slightly different. We are creating users, and we have 5 users. RXIN, J. Gonzal, Franklin, Estonica, and Peter. 37524. Next, we are creating edges for those users. So we have an edge from 3 to 7, 5, 3, 2, 5, 5, 7, 4, 0, and 5, 0. And those two edges are suspicious. They are suspicious because there is no vertex here with such ID. So this is a missing one and missing one. So we are missing 2 vertices, but we still have edges to them. And GraphX API has a default for such situations. So we are creating a new graph, passing users here and relationships. But also we are passing a third parameter that is a default vertex attribute. We are passing a default user here. So if we will be doing some operations on this specific edge that has vertex to not existing one, it will be switched for that default user. So Joe Doe will be a missing vertex. So will be relationship between Peter to Joe Doe, 4, 0, and also from Franklin to Joe Doe. But let's see a subgraph method. So firstly, we are analyzing our graph, so we want to reason about our graph. So we are using our method that we learned about in the previous video, in the previous section. That is a triplets method. We are taking all triplets and we reason about the graph, mapping it to the string that is a human readable. Next, we are removing missing vertices and edges connected to them. So we are executing a method subgraph that has an ID and attribute. Next, we can filter out something from that graph and it will create new graph that is a valid one. So we are filtering if the attribute, second attribute of the vertex, as we remember here is stud student, postdoc, prof student, but we can see that default user has an attribute equal to missing. So if the second attribute is equal to missing, it means that this is a not valid connection between edges and vertex. So we can use that fact and filter out if the attribute second one is different than missing, then we will keep that in the graph. So we are creating a valid subgraph that we'll call a valid subgraph. Next, we are printing all vertices and triplets again. So we are mapping it to a human readable string to be able to reason about it. And we are printing that graph. So let's start our method and we will see how does it behave. So we can see that firstly, there was 1, 2, 3, 4, 5, 6 facts about our graph. But 2 relationships are suspicious because there is a Peter is the student of John Doe and Franklin is a colleague of John Doe. But we can know here from this point that there is no something like John Doe. He is a missing user. So after filtering out that missing user and creating a subgraph without that relationship, we are getting only 5 one. And when we reason about our graph, printing our facts, we can see that relationships to the John Doe are removed. So we have 4 facts and we have a valid graph and all edges and all vertices are present in the subgraph. Then we are able to do some operations on this subgraph. So we achieved our result using the subgraph method.